classification of numbers. Okay, now before understanding the classification of numbers, let's understand what numbers actually are. Okay, so आसान भाषा में numbers are anything that can be quantified. Anything that can be quantified is a number. So one night at call center, two states, three idiots. These are numbers that you can quantify, and hence they are called as numbers. Now, very smartly, I've taken the example of numbers that you can observe in nature, right? So these numbers are called as natural numbers. Okay, counting numbers from one. Okay, 1, 2, 3, 4, 5. They are called as natural numbers. But we realize that out of along with these numbers, we also need to quantify something which is not there, nothingness, right? And that is zero. So the set of natural numbers, when you add zero, you get a set of whole numbers. Then in this world, trade came about. Okay, and whenever there is trade, whenever there is business, there is profit or loss. So profit is plus, loss is minus. So that brings us to the next category of numbers, and they are basically called as integers. Integers are basically whole numbers with a plus or a minus sign. Okay, so 1, 2, 3, 4 positive numbers will go on till plus infinity, and negative numbers -1, -2, -3 will go on to negative infinity likewise. Okay, now integers are denoted by the symbol Z, whole numbers by W, and natural numbers by N. Sorry, I forgot to mention. But we realize the limitation of integers also. Why? Because in the modern times we started making pizzas, right? So a medium pizza generally consists of 6 pieces, right? So you have different options to consume the pizza. You can consume 1 out of 6, you can consume 2 out of 6, so on and so forth, up till 6 out of 6, the entire pizza, right? 6 out of 6 basically is the whole pizza. It's basically equal to 1. So all these numbers, 1 by 6, 2 by 6, 3 by 6, they are a part out of the whole. And these parts out of the whole are basically called as fractions. Okay. Now, fractions are categorized into two: proper fractions and improper fractions. Let's understand the distinction between them. So, guys, in the fractions, the upper part, okay, the part here, ऊपर वाला जो part है, हिस्सा है, the whole का, okay. So the part is basically the numerator, and the whole is the denominator. Okay, so whenever the part is lesser than the whole, it makes sense. We have a part of something, right? It's a proper part of something, hence it's called as a proper fraction. On the contrary, whenever the part is greater than the whole, we call it as improper. Okay, something which is improper, right? आपने बगल वाले का भी एक पीस उठा के चोरी करके खा लिया. So you are eating 7 out of 6 pieces, right? That's improper, and that's why the fraction they represent in this form, they're called as improper fraction. See, it doesn't make sense. If the whole is consisting of 6 parts, okay, the part cannot be greater than the whole, right? So the fractions are improper. Why? You can further reduce them. Okay, so the further reduction of fractions we'll see now. Improper fractions can be further reduced. Okay, let's say I take 7 divided by 6 only as an example. So 6 ones are 6, the remainder is 1. So write the answer. The quotient is basically, this part is called as the quotient of the division. Write the quotient as such, the remainder 1 and the divisor 6. So 7 by 6 can also be written in this form as 1 by 6 in the mixed form. All right. So always remember, improper fractions can always be represented in the mixed form. Okay. Just one more way of writing them. All right. Now, since I have written fractions, okay, 1 out of 6, 1 is out of 6. 1 out of 6 kitna hota hai? For this, we immediately pick up the calculator, and the calculator says 1.66667. Okay, so basically this is nothing but 1.666, okay, recurring. Okay, similarly, if you write 3 out of 6, 3 out of 6 will be basically 0.5. Okay, so now the fractions can be further converted to decimals. All right, and decimals are of two types: the terminating decimal and the recurring decimal. Okay, terminating means that the division is said to have terminated, finished. Okay, and recurring means the division is said to reoccur, so recurring. All right, so decimals, two categories: terminating and recurring. Now, whatever we have discussed till date, okay, we are putting all of that in a box, and that box is basically called as rational numbers. All right. So rational numbers are all the numbers of the form P by Q with two conditions. P and Q should both belong to integers, and Q should not be equal to 0. All right. Okay. We know that anything upon 0 is basically not defined. Okay. So when Q becomes 0, the entire fraction P by Q becomes not defined. Hence, Q should not be equal to 0. All right. Now, P by Q में P और Q integer होने का meaning ये है कि by taking any values of P and Q, you can get all the categories of numbers we have discussed so far. Right. If you take P as, let's say, -10, And if you take q as, let's say, 2, minus 10 upon 2 is basically minus 5, right? It's an integer. So we have represented all integers ka category in this way. Okay. You can also take, let's say, p as 10 and q as 5. The answer is 2 plus 2. So whole numbers are gaye or natural numbers are gaye. In fact, if you want to take whole numbers, let's say p is 0 and q is 5. 0 upon 5 is 0. Anything 0 upon anything except 0 is basically 0 only. Okay. Denominator में 0 नहीं आना चाहिए. Numerator में 0 is acceptable. Okay. अगर दोनों में आता है 0 by 0, still it is not different. Is that clear? Okay. So that's how we have taken into account the whole numbers also. Now, if you don't want to reduce them, take p as 1 and q as 3. 1 by 3 is a fraction. Okay, convert it to 0.3 recurring. It's a decimal. So basically, p by q form mein you can represent all of these numbers. They are called as rational numbers. Okay, it's not rational is called as irrational. Okay, so root 2, root 3, root 5, root 7. We'll discuss all this in the upcoming classes. They are all irrational numbers, numbers which are neither terminating nor recurring. Okay. So there are very classic examples here for the irrational numbers. Pi, you might have heard, very common example. The next number is basically E, the Euler's constant. Okay, not very significant right now. We'll discuss about this in detail. 2.718 ke aaspas iska value. The next number, the next interesting number is phi, the golden ratio. Okay, so rational and irrational numbers combined together, okay, they are called as real numbers. Okay, so basically all the numbers which I've discussed right now, they are nothing but real numbers, simply because there is a real number line, in which you can represent them. We'll discuss that. A line here, real number line, where you can specifically plot all these numbers. Okay, so they are basically real numbers. Okay, so as I said, you can plot the real numbers on a real number line. So if I ask you find out root of 25, you will say yes, I can plot root 25, which is plus 5. If I ask you root of 121, you can say yes, plus 11 also I can plot. Okay. So two things to learn from here. First is whenever you take square root of a positive number, the answer is positive. Okay. But if I ask you square root of a negative number, the second thing to learn, okay, it's not possible, right? Because अगर हमने एक negative number को भी square कर दिया है, okay, the answer is always positive, right? Okay, all the numbers, okay, having a radical sign, basically root sign, और उसके अंदर एक negative value हो, they are basically imaginary numbers. Okay, you can always split like this. Okay, now root 25 we saw just now is plus 5. Okay, इसका algebraic reason भी अपन देखेंगे आगे जाके क्यों होता है plus 5 specifically. And this root of -1, guys, we call it as iota, I, the Greek symbol I. So root of -25 is nothing but 5i. Okay, now when you square 5i, you get 5 square into I square. Remember, I is square root of -1, so I square is -1. Okay, so 5 square is 25, 25 into I square, it's basically -25. Okay, so this is how we complete the discussion for numbers. Okay, the complete hierarchy of numbers are explained. If you have any doubts, you can just revisit the entire video. Yeah, just revisit this part here. You'll get more clarity.